Okay, we're going to pause the video here so that you can copy down the warm-up and try these two problems. Check with the neighbor if you're stuck. Do not sit there doing nothing. Make sure you're getting help if you can't do them. Then we'll resume the video in a few minutes so that you can check your work and check your answers. Okay, for A, I need to do g of f of x. So that means I'm taking 2x minus 9 and plugging it into any x in the g function. That happens here, so I get 2x minus 9 minus 5. I have to simplify that. Now remember, when we find the domain for a composite function, we first say, are there any restrictions on the inside? Any restrictions on a line? No. So then we look at the entire result. Are there any restrictions when there's a fraction? Yes, there is. You cannot divide by 0. So to find the domain, 2x minus 14 cannot equal 0. I'm going to solve for x. So x cannot equal 7 is my domain. And 2 over 2x minus 14 is my function. Okay, we're going to do something similar for b. I need g of f of x. So I'm going to plug the square root of x plus 2 in for this x. And there's my composite. For the domain, are there any restrictions for the inner function? Yes, it's a square root. We can only square root 0 or positive numbers. So x plus 2 needs to be greater than or equal to 0, which means x needs to be greater than or equal to negative 2 for your domain. Then we have to check, are there any extra restrictions from the composite? There's not. This radical is the same, so our domain is x is greater than or equal to negative 2. We're going to practice more composite functions today. So again, we're going to pause the video here for you to try these 4 problems. Then we'll resume so you can check your answers. So for number 1 with addition, I have f plus g. I'm going to combine my like terms. There are no restrictions on this function because it's linear, and lines can go for all real numbers from negative to positive infinity. So let's try 2. So that's 2 minus 4x, and again, that's all reals. Sorry, I should have written that. For your domain, because it's linear again. Now for 3, you have to be careful with your signs. It's minus the entire quantity of 2 minus x. This negative gets distributed to both pieces. So this is 3x minus 2 plus x, which is 4x minus 2. And again, the domain is all reals. So 6x, and again, the domain is all reals, because all of these are just lines. Okay, so here's 2 more. Pause the video so you can try these 2. Don't forget to state the domains for both. Number 6 is multiplication. So I have a number times a quantity. So 2x squared times x and times 3 gives me 2x to the third plus 6x squared. The domain x is all reals. There's no square roots, there's no fractions, so we're okay. Now for 8 with division, that's a red flag to me. It's screaming at me, Mrs. Weiss, we're going to have a restriction on our domain with a fraction. So f is on the numerator, g is our denominator. Now with a fraction, the denominator cannot equal 0 for the domain, so x cannot equal 0. Okay, so here's 4 more problems. Pause the video to try these. For A, we're going to do f of x squared. So anywhere there's an x, I'm replacing it with x squared. B, it's g of 3x minus 2. That means I have to plug 3x minus 2 in anywhere there's an x. And I hope you did not go to math jail in B. Because for B, when you have 3x minus 2 squared, that means 3x minus 2 times 3x minus 2. You cannot distribute a square. If you want, there's a video on YouTube about math jail describing this exact situation. When we're here, we're going to multiply our binomials together. And combine like terms. And that's our answer. Now for C, we're going to do f of itself. So that's 9x minus 6 minus 2. I distribute the 3. Combine like terms, we get 9x minus 8. Oh, the domain of each one. So back here at A, are there any restrictions on the inside? No, because it's not a fraction, it's not a square root. Are there any restrictions on the composite? Nope. So x is all reals. Same thing for B. Any restrictions on the inside function? No, it's a line. Any restrictions on the final composite? Nope. So x is all reals. Restrictions on the inside? No. Restrictions on the rest? The complete answer? No. So x is all reals. Okay, for the remainder of class, you're going to do this page in your packet. This is actually the homework. We can start it early. It's not due until the 19th. We have the long weekend and the Jewish holiday in between, so if you're celebrating, you're not pressured to do your homework this weekend. You can do it after the holiday. We're not going to check for it till the 19th. So for the remainder of class, you're going to work on this page. All of the answers are in the back of this flip chart on Edline, so you can check your work from home.